Welcome to Neurodegeneration Awareness and Artificial Intelligence, the podcast where we explore the scientific frontiers between AI and neurobiology. I'm your host, Sukant. Today's episode, Predictive Analytics in Neurodegeneration Awareness, takes us deep into how advanced data science is transforming our ability to anticipate, stratify, and intervene in neurodegenerative disorders. Joining me is the same cast as last time, very accomplished Alfredo, Malika, Kaniz, Kanak, Sahil, Aditya, and Jindyasa. Very happy to have everyone here. Let's straight away dive into the questions. Let's begin by mapping the landscape. What are the persistent gaps in predictive analytics for neurodegeneration, especially from a clinical and translational perspective? Alfredo, what are your thoughts?
I think a primary challenge is the profound heterogeneity of disease progression in disorders like Alzheimer's and Parkinson's. Traditional risk models often underperform because they don't account for polygenic risk, environmental exposure, or subtle prodromal phenotypes. This severely limits early intervention and personalized care, I think.
Absolutely, like what Dr. Alfredo said, another major gap is the integration of multimodal data genomics, I feel, like also imaging, digital biomarkers, and EHRs. Most current analytics are siloed, thus missing the synergistic insights that multi source fusion can provide us. Moreover, there is a lack of validated, generalizable models for non Western populations, particularly, which thus raises equity concerns.
Yeah, and if we look from research perspective, longitudinal data collection and missingness are persistent issues. Many cohorts have irregular follow-up, and patient attrition can bias predictive model. So there is a pressing need for robust imputation method and federated learning to address these gaps.
Very well said. Now let's look at AI solutions and innovations. How is AI advancing the field to address these challenges? Sohit, let's start with what do you think are the most promising AI tools and frameworks that you have seen?
Yeah, when I think of AI tools or frameworks, I think of natural language processing, which we shortly call NLP, is enabling the extraction of nuanced clinical phenotypes from unstructured EHR notes, I mean, electronic health records. So, transformer-based models can identify early cognitive complaints or motor symptoms that precede formal diagnosis, thus like improving risk stratification.
In addition to it, I think the deep learning in on neuroimaging data is another leap forward. Like convolutional neural network can detect subtle patterns of cortical thinning or white matter hyperintensities that correlate with the prodromal neurodegeneration. And some platforms now integrate imaging with the polygenic risk scores to enhance predictive accuracies.
Also, on the data science side, unsupervised clustering algorithms like TSNE and UMAP are being used to identify latent patient subgroups with distinct progression trajectories. This supports precision medicine by tailoring interventions to cluster specific risk profiles.
There are also ensemble techniques such as random forests and gradient boosting, which is showing promise in forecasting conversation from mild cognitive impairment to Alzheimer's. These models can incorporate time series data such as longitudinal cognitive scores for dynamic risk estimation.
Yeah, like there's also a growing interest in federated learning for privacy preserving predictive analytics. Like by training models across decentralized data sets, institution can collaborate without sharing the raw patient data, like which is really very crucial for rare neurodegenerative conditions.
Importantly, explainable AI is something which is gaining traction. Tools like SHAP, which is like Shapley Addictive additive explanations, and LIME, which is local interpretable model agnostic explanations, are being integrated to ensure that such risk predictions that are being made are interpretable to clinicians, patients, and caregivers, thus getting rid of the black box problem and thus supporting regulatory compliance.
That's right. Recent studies affirm these advances. For instance, a 2024 multi-center study demonstrated that combining digital biomarkers from wearables with EHR-derived features significantly improved early prediction of Parkinson's progression. The integration of multimodal data and interpretable models was key to clinical adoption.
Yeah, that's very well said. That integration of multimodal data and interpretable models has been a key to clinical adoption. Multimodal data has sort of been more, I would say, more advanced. Interpretable models are still coming up. And as academicians do, they like to argue. There are still arguments that whether it is still sufficiently black box and not interpretable, or it's just a mild improvement or a leap forward. But interpretability is working, moving fast, and there is still quite a bit to go forward in this. So there's a lot happening in that sphere. Even we are doing some active research in that area. So very well said, Alfredo. Let's move to the real thing of building and scaling sort of communities. What's required to scale AI facilitated predictive analytics safely and ethically in neurodegeneration? Like to hear from everyone on UX, privacy, moderation, and multilingual access.
So, data governance is foundational. End-to-end encryption, federated analytics, and differential privacy must, of course, be standard to protect sensitive health information. Consent net frameworks should be dynamic, thus allowing users to modulate data sharing as their comfort evolves.
Right, and I would like to add that cultural and linguistic adaptation is essential. AI models must be fine-tuned on local corpora, and interface design should reflect cultural norms such as collectivist versus individualist preferences in group interactions. Continuous validation is needed to avoid algorithm bias, especially in underrepresented populations.
Also, the accessibility is multifactorial. The user experience and user interface must accommodate motor and cognitive impairments. Think voice navigation, simplified layouts, and compatibility with assistive devices. And low bandwidth and offline modes are also essential for resource limited settings.
Yeah, hybrid moderation, combining AI triage with human oversight remains the best practice. Like automated systems can flag crisis language or aberrant behavior, but escalation pathways to train clinicians or peer moderators are very critical for safety.
Exactly. Along with the safety, affordability and sustainability must also be addressed. Open source platforms and partnership with public health agencies can facilitate broad access. Then implementation science frameworks such as REAIM, that is reach, effectiveness, adoption, implementation, and maintenance can guide scale up and evaluation.
Yes. Transparent communication about AI's role is necessary for trust. Users should know when they are interacting with AI versus humans, and clear escalation protocols should be built into every deployment.
In non-English dominant countries, multilingual access is very vital. AI interfaces should support local languages and dialects, ensuring inclusivity and reducing disparities in predictive health analytics.
Yeah, so like in my view, continuous feedback from both clinicians and patient is like a key to the ongoing improvement, right? Like by involving them through participated design, we can ensure the technology stays relevant and truly useful in the like clinical settings.
Okay, that's really interesting perspective on relevance, inclusivity, and effectiveness. A very good discussion today. Today's discussion highlights the transformative potential of predictive analytics in neurodegeneration if deployed with rigor, equity, and empathy. I'll also say one other thing which people don't say often. Without building too many partners, more integrated thing and profitable so that government alone is not implementing. Because when left for government, there is a lot of room for bureaucracy. When left for multiple steps, there's a lot of room for legal aspects, which skyrockets the cost of healthcare. US is an example of per capita insane spending. So I think integration, which can even scale up and is profitable to the provider, is also necessary for its widespread adoption. Let's close with one step, one sort of sentence, one soundbite insights from each one of you.
Well, I would say that integrating multimodal data and explainable AI will drive precision prediction and intervention in neurodegenerative diseases.
Yeah, and I feel that an ethical, scalable, and culturally attuned AI is absolutely essential for equitable impact in predictive neuroanalytics.
And as I said earlier also, that federated learning and participatory design are key to robust, inclusive predictive models.
And according to me, accessible interfaces and continued validation will ensure AI's benefits reach all persons and patient populations.
Yeah, well, as I said earlier, hybrid human AI systems are the future of safe, responsive, predictive healthcare support.
Also, transparent, interpretable analytics build trust and drive clinical adoption.
Multilingual adaptive AI can democratize predictive care in neurology.
Yeah, so like continuous feedback from real world user is critical and important for impactful innovation.
Well, big thanks to everyone, Professor Alfredo, Professor Mallika, Professor Kanis, Sohit, Kanak, Sahil, Aditya, and Jidnyasa. You made this discussion very alive and kicking. That's all for episode 5. Thank you, everyone. Bye bye.
Thank
Thank you.
you. Bye.